Hello and welcome to this project on face swapping. So in this project, we will be using OpenCV and dlib to extract faces of humans. We will use a source image and a destination image, and we will try to replace the face of the destination image with the source image. We will be using some pre-trained model which will extract the landmarks from the faces. So in order to solve this problem, in order to make this project, we will follow these 10 simple steps. So initially we will download the pre-trained model for shape predictor. Then we will be creating a function for extracting the index of the images. Next we will load the source and the destination image from the internet using the request library. Then we will convert those images into a NumPy array. Then these NumPy arrays will be converted into grayscale images for better results as they lower down the complexity of images. Next we will load the face detector and the face landmarks predictor using the dlib library. After that we will perform some triangulations on the images to cut out the face, and then we will create some empty mask for the images. Next we will swap the image for the face on the destination image, and in the end we will be using seamless cone to adjust the color scheme of the destination image with the initial image, the source image. So we will be using dlib for this project, and it's a landmark facial detector with pre-trained models. dlib is used to estimate the location of coordinates, that is x and y, which maps the facial points of a person's face. This project can be used for learning and understanding different concepts of computer vision. This project can also be used to build augmented reality applications like Snapchat, etc. So let's move forward and create this project using Google. So for this project, we will be using Google Colab, as Google Colab provides high computational power, and both OpenCV and dlib requires that. So as we know that we are working on a face swapping app project. So in this project, we will be using different functionalities of OpenCV and dlib to extract the faces of our human beings from a given image. We will also use a pre-trained model to extract the landmarks from the faces. So let's get started. Initially, we need to import some required libraries, as you can see here. So here you can see that I have imported CV2, which is OpenCV, required for image processing functionalities. We'll use and import NumPy for mathematical computation. We will also import dlib, which will be used for pre-trained model extraction. Other than that, I have imported request, which will be used to fetch the URLs from the internet for downloading the image or loading the pre-trained model. And we will use image from PIL, which will be used for loading the image, displaying the image. So let's run this cell and import these required libraries. Here you can see that the cell is running, so our libraries are getting imported. So as soon as it gets imported, we will move to the next step, and the next step is we will download the pre-trained model for shape predictor. This is the URL for the GitHub where the pre-trained model is stored. Here you can see that the name of the model is shape predictor 68 face landmarks.dat. We will download this using wget function. Let's run this cell and download this pre-trained model into our Google Colab. This link is of a GitHub account where this model is being stored. We are downloading it from that GitHub account. So here you can see that our model has been downloaded. It's around 112 MB and it's stored in our Google Colab. So now next we will create a function which will extract the index from the NumPy array. So here you can see that the name of the function is extract index from NP array. We are defining the index as none. and we are defining a for loop which will extract the index and store it into a num variable, and it will return the index. Let's run this cell and create this function. Now next we will see how to read the images using the URL. So here you can see that I have taken a URL from the internet, and I'll use this as our basic image, the source image. You can take any image and then we will resize this image. Let's run this cell and load this image into our Google Colab. So this is our source image from which we will cut out the face and swap it with the another image, the destination image. So now let us download our destination image. Here also you can see that I have used a URL. You can take any image from the internet. So this URL will be fetched by the request library, as I've already told you, and this request library will pass it to the image function, function of pillow library PIL. Similarly, we'll also resize this image to 300 by 300. So now let's load this image and see which image we are using. So this is our destination image. You can take any image as you want. It's just that we need to extract the faces, so the face should be clear in the image. Now let's move forward. So here you can see that we will convert our images into a NumPy array, as you can see here, np.array image1. Similarly, we will use cb2, that is OpenCV, and a function called cvt color. What this will do is, this will convert my image into a grayscale image. So image1 is our source image. We are converting into a NumPy array, and then we are converting into a grayscale image. Similarly for the image 2 also, we are converting into a NumPy array. Image 2 is a destination image, and then we are converting into a grayscale image. Here you can see that I have also created a mask which is similar to the source image, the image 1, and it will contain all zeros. This image will be stored as a NumPy array and it will contain all zeros. Let's run this and create our mask and convert our images. So here it has created an empty mask and also converted our images into grayscale. Let's move forward. So next what we'll do is we'll load the face detector and face landmarks predictor using the dlib. So here you can see that we have loaded the detector using dlib.getFrontalFaceDetector. It is already defined in dlib, the getFrontalFaceDetector function. Similarly, we'll use the shape predictor, which will be loaded using the shapePredictor68 facelandmarks.dat file. After loading these detector and predictor, we will store the height, width and channels of the destination image using the image2.shape function. Other than that, we are also creating a new face, that is np.0, and pass the height, width and channel. Let's run this cell and create the empty image with zeros. So this cell has completed. So our empty image has been created, which will be used further for face swapping. Now this is the most important part. Here you can see that firstly we are working on the face 1, that is the source image. In this source image we are creating a function which will detect the landmarks using the predictor function and store them. So first we need to pass the image to detector, then that object will be used to extract the landmarks using that predictor. Then storing the extracted landmarks points x and y into the landmarks, as you can see here, x and y. And we are going to segment these into the triangles. So for that, we are using this points equal to np.array and convex hull. Similarly, we'll pass this convex hull and the mask into convex poly and apply a bitwise operator on the face 1 image. After that, you can see here that we are doing the triangulation. So the triangulation, we are using the bounding rectangle and pass our convex hull as we have created above. Similarly, we'll also divide it into a 2D using the subdiv function. Next, this subdiv function will insert the landmarks point also, as we have found above. Similarly, triangles also using the get triangles list, and then all this is stored into a numpy array. So here you can see that the triangle is stored into a numpy array using the np.array. Next, what we'll do is we'll find the indexes of the triangles. So for t in triangles, we'll store 3 points and we'll store the rectangle indexes into these points. Next, you can see that we have created an index point 1 where we have used np.where and we are storing the points where points equal to point 1 and all axes. Similarly for point 2 and similarly for index point 3. In the end, what we are doing is we are finding out that if index point 1 is not null and index point 2 is not null, and similarly for index point 3, then the triangle will be index point 1, point 2 and point 3, and we'll append the triangle into indexes or triangle. So this is the most important step to find out the triangulation of the images. We are working on the source image. So let's run this cell and complete this step. So as you can see, it's completed. Now we'll perform the same operation for the destination image, the face 2. We are also extracting the landmarks for the image 2. So let's run this cell and perform the same operations for image 2 also, that is the destination image. The next step will be creating an empty image with zeros. Why this is important? Because it will be used for further processing for face swapping. Let's run this and convert new faces and new mask. Next is the triangulation of both the faces. Here you can see that what we are doing is we are creating a for loop in which we are trying to triangulate the first face. Here you can see in the first point, what we are doing is we are passing a landmark point with the index 0. Similarly for point 2 and point 3. And all these points are further stored into a numpy array. After that, we are creating a bounding rectangle which will bound the image, bound the face, and we are taking its coordinates x, y, width and height and store into a rectangle. Similarly, we'll crop the triangle from the image as we have already triangulated it, and next we will create the mask. Here you can see that we have created the mask using the np.zeros and pass the height and width of the mask. Next we will store all these points and the x and y values, that is the x and y coordinates, into a numpy array in a variable named points. Next you can see here that we are creating a line space. Line space is required for the mask. So we are using the cv2.line function, passing the line space mark and passing 2 points, point 1 and point 2. Similarly, for the second line we are passing the point 2 and point 3, and for the third one we are passing the point 1 and point 3, and then we are applying a bitwise operator here. As we have done the triangulation of the first phase, similarly this step, the triangulation of the second phase, is exactly same. Here also we are creating 3 points, saving them into a numpy array, creating a bounding rectangle, and all the steps are exactly same as we have done above. In the end, we are warping triangles. Here you can see that we have used points, which is np.float32 points as we have already defined above, and a point 2 also for the second image. We are using a function called cv2.getAffine and it will transform both points 1 and points 2. Similarly, we are using the warp triangle, which will contain the warp affine cropped triangle, the crop triangle as we have found above. Next, we will use the bitwise operator and pass both the warp triangle and the mask. Till here, our images have been triangulized. Now next what we'll do is we will reconstruct the destination face. So we have extracted the face from the source image and we have deleted the face of the destination image. Now we'll replace the destination face with reconstruct the destination face using the CVT color and threshold function. Here you can see that we are using the CVT color function and threshold. Finally, we'll use the bitwise operator, and here you can see that we are finding out the image to new face rectangle area and passing the image to new face and the warp triangle. Let's run this cell and complete this step. So what we did here we performed some of the operations similar to the destination image as above. After that, we have the triangulation of both the faces. We take the triangle of source face and we extract them. We also need to take the coordinates of the triangle of the destination face so that we can warp the triangle of the source face to have the same size. Next, what we will do is we will face swap. So once we have cutted and wrapped the triangles, we need to link them together. We simply rebuild the face using the triangulation pattern we have found above, with only difference that this time we will put the wrap triangle around it. So here you can see that we are using the fill convex poly function and the bitwise function for this. Let's run this cell and face swap it. So it's done. Now the face is ready to be replaced, and now we cut out the face of the destination image to make space for the new face. So we take the new face and the destination image without face and we link them. Here you can see that I have taken the image of the with no face and the new face and we are adding it. So the result will be a new face on the destination image. Let's run this. It's completed. Finally, the faces are correctly swapped and it's time to adjust the color. So we need to adjust the color also in the source image to fit in the destination image. So on OpenCV, we have a built-in function called seamless clone. As you can see here, I have used seamless clone. What it does is it matches the destination image with the current image that we are using. So we need to take the new face created on the 6th step and take the original destination image and its marks to cut out the face. We need to get the center of the face. Let's run this and use the seamless clone function. Finally, we'll print out the final image, the seamless clone that we have created. Let's run this cell and see the image. So here you can see, here you can visualize the output NumPy image, which we have converted using the pillow into an image object. And this is the final swapped image. This is the destination image swapped by the face of the source image. So with this, we came to the conclusion of this project. So We started with downloading the pre-trained model for face landmark and downloaded the image from the internet that we worked on. We use CV2 and dlib for a lot of pre-processing, as you have seen here, for both the images, and we use different functionalities to make reach to the end, which is swapping the face of the source image with the destination image. So the scope for this project will be, this project can be used for learning and understanding different concepts of computer vision. It is a fun project. And this project can also be used to build augmented reality applications like Snapchat, etc. So next I'll show you how to create a application for this project. So let's move forward. Now we will create a Flask app of our face swap application. So here you can see that I have created a folder named face swap app and I have created certain files in it. Let me show you all the files one by one and what they do. So initially you can see here that I have opened the config.py file. So in config.py file we define the configuration. So here you can see that I have imported class config object and I have passed the secret key as PyAnalytics. You can change it to anything that you want. We will also set the session cookie secure as true and default theme as none. And for the development config class, we will set debug equal to true. Now let us see the app.py file. So this is the app.py file, which is the main file which will run the app. So here you can see that it is importing app from app, and whenever main is encountered, app will be run using the app.run command. Other than this, here we can see the init.py file in the app folder. So init.py file is the initializer. Here you can see that we are importing Flask from Flask and we are passing the name of the app. Similarly, we are calling the config file as we have already defined that in the config.py, and we are calling the development config from that. And after that we are importing views from app. So let us see the views.py file. So this is the views.py file. This is the important file where all our code will be stored. The code for the application that we have already created, the code for the project. So let's see what all it contains. So initially we will import all the required libraries. As you can see here, we are importing Flask. We are importing request and render templates URL from Flask. We are also importing computer vision, NumPy, image, string, random, OS and dlib. So after that we will add the paths to the configuration. So here you can see that we are using the initial file uploads path and passing the app static uploads. That is the app folder static, and in the static folder there is an upload folder. So we are passing that path here. After that we are saving our pre-trained model, as I have shown you in Colab code, our pre-trained .dat model, which we downloaded from GitHub, and storing it into a variable named shape predictor face landmarks. Now we will repeat the same exact code as we did in the Google Colab. Here you can see that we are extracting the index of the NumPy array. We are getting an image of the that we will be working on, image.open, image.resize. Then we are extracting the index of the image. So an app runs by two methods, get and post. So get is initialized in the first phase. So get will it will load the index page, and as soon as we click any button or we do any action on the home page, it will activate the post method. So in the get method we have set index.html, which is the main file, the home page, and in the post method you can see that we are uploading images that we want to swap faces of, and exactly same code that we have done in the Google Colab. So we are generating a unique name to save the images. After that we are saving the images. We are using the dlib library to get the frontal face. Then we will do the triangulation as we have already did in, you have to paste that exact same code from your Google Colab in this views.py file. This views.py file is opened in a code editor because it is a Python script. You can use any code editor. I am currently working on Atom. Here you can see that it is the exact same code as we have did in Google Colab. We are founding the bounding rectangle, we are founding the landmarks point, we are creating the triangle list as I have already shown you in the Google Colab. So let's skip this. You can copy that code, exactly same code here. This is the exact same code as we have did in the Google Colab. So in the end, after all this code we copied from there, we'll save the result into initial file upload path as we have already defined above, and we will return the render template index.html. After that, we have called the main function, the app.run, which will run the app. Now let's see how we design the front end of this app, how this app will look. So for that, we need to go to the templates folder, and in the templates folder I have defined a file index.html. So in order to understand this index.html file, you should have a basic understanding of CSS and HTML. So CSS and HTML are used to define the front end of any application. CSS is used for styling and HTML is used for designing the divisions, containers, etc. So here you can see that I have used materialize.css, which is already stored in static folder. In the static folder, you can see that we have CSS folder which contains materialize.css and materialize.min.css. In the dat folder, we are storing our already trained model that we downloaded from the internet. In the images, we have stored the white background image that will be used as a background image for our application. We are also using JavaScript, so we have stored materialize.js and materialize.min.js here. And similarly, the uploads, where the images will be uploaded. So let's get back to this index.html file and let me show you how I designed it. So initially I made a container which will show face swap app and made by PyAnalytics. So this is our first division. After this division, I have created two containers which will upload the source image. I have given a browse button which will browse for the source image, and we will similarly upload the destination image using the browse button for that also. After doing that, we just need to click a swap button, as you can see here in the fourth division, and this will swap the images from the destination, the source. In the end, you can see that I have written some scripts. So these scripts will work in running the above written commands. So whenever we click on browse or whenever we click on swap, what should happen? These scripts will tell them. So this is the index.html file. It is the most important file as it will design the front end of our app. So if you know HTML and CSS well, you can design your own front end. Now let's move forward and let me show you some of the other important files. So this is the proc file. A proc file is generally important when we deploy the app. So a proc file, as you can see here, it contains web, which will tell the deployment app that this is a web app. And similarly, Gunicon will run the app from app. And here you can see that we have set the timeout as 60. So it will be 60 seconds. It will wait for 60 seconds after we click any button for timeout. Other than that, I have also created a readme file. This contains all the steps how you can run this app. We'll see that later. And the most important file, that is requirements.txt. So requirements.txt file is the most important because it contains all the requirements all the dependencies of our project. So what do we mean by dependencies or requirements of our project? So here you can see that it is showing us that dlib equal to 19.21.1. So this is the version of the dlib. Similarly, numpy, opencv, flask. So what requirements.txt does, it creates a requirement.txt file which contains the library names with their version that are used to run this app. So in case you don't know what all libraries and versions you are using, you can create this requirement file on your own. So let me show you how you can create this requirements file on your own. But for that, you need to copy the path of this folder where your app is stored and open the Anaconda command prompt. Let me show you how to do that. You just need to copy the path of the folder and open Anaconda command prompt. So this is my Anaconda prompt. I have copied the path of the folder where I have saved my project. Let me move to that path for using cd, that is change directory, and copy the path here. So I've got inside that folder where my app is stored. Now we will use the command pip reqs. So to run this command, you first need to install pip reqs on your system. And if you don't have that pre-installed on a system, you can install it using pip install pip reqs. So what this will do, this will install this pip reqs library on your system. So as I have already installed it on my system, it's showing me requirement already satisfied. Now we will make that requirements file using the pip reqs file. So pip reqs. So this command will create a requirements file in my folder which will contain the requirements that is all the libraries that are required to run this project. So I have already shown you that I have created that file and it contains all the libraries that are required for my app. So it's giving me a warning that the file is already existing. Next, so in order to install all the dependencies, in order to install all the libraries that we will use to create this app, to run this app, we need to install all the libraries that are required in this, that are defined in this requirements.txt file. So let me show you how you can do that. So for that, you just need to run a command pip install -r requirements.txt. So what this will do, this will install all the requirements that are there mentioned in your requirements.txt file. Here you can see that it is downloading the numpy. Similarly, all the other libraries that are required. It can take some time. If you don't have these libraries already installed in a system, it will take some time. So here you can see that all the libraries that were required and were mentioned in requirements.txt file, all of them are downloaded here. So now we just need to run our app, and for running our app we will use the command. We first need to move to this folder, so we are already in this folder. Now we need to run our app, which is with the name of app.py. So we need to run the command python space app.py. So here you can see that it is running on this server, this URL. So let's copy this URL and open it in our browser and see if it works. So here you can see that I have copied that URL in my browser, and this is my app as we have created. Now let's check if it's working or not. So we will browse some images. I've already stored it in the sample image. So this is the source image, say, and we will also browse the destination image, and let's swap these images. So here you can see that our app is working correctly and it's working fine. So with this, we came to an end of this project. You can design your own front end as I have shown you in the index.html file. Also, you can use different images for face swapping. Thank you.